All right, does that work? All right, thank you all for coming. I've never done anything like this before. I've done some regular YouTube videos, but never a live stream. So a few technical things that I had to figure out and still figuring out live. So this will be exciting, not just for me, but for all of you watching in the audience. Tell you just a tiny bit about myself. Most of you already know me, but I've been a member of this museum for about 14 or 15 years. I got into radios when I was about 8 years old. My parents and I would set up antique flea markets all over the Southeast. And so from a young age, I was looking at a lot of antiques and old radios. I don't know what it is. I just glommed onto them immediately. And long story short, I moved out here several decades ago and found this museum. And my volunteerism, one of the things I do is restore tons and tons of these AA5s. And when I first joined this museum, well, let's just back up from I'm a creative director, which means I look at advertising and artwork and push pixels around all day. I'm not an engineer, and so this is all new to me. And a lot of the people at this museum kind of showed me the ropes of it. A lot of it just came from trial and error. And I remember feeling a little bit, what's the word I'm looking for? Intimidated by it. Because people using a lot of phrases like, what's your biggest plus? And I was like, I don't know what big plus is. And it took a while to learn, but to this day, I still refer to things as kind of a flat out decisions. I'm going to work on it. Let me back. What we have here is a post-war Motorola set. And I'm going to restore it in a typical way. And what I want to do is make it so that those of you who may not know this technical can maybe understand what I'm doing. Most of these radios are millions. We call it 805s because they're going to be generally 5 tubes. And these they call them what they did back in the days of space. So if you're going to have Christmas lights in your house, it's the same thing. This is isolated area, meaning isolates you from ground. That's important because if you're ground and touched something like this in a lot of the orange hot steps, you come ground. You could complete the circuit. So this provides a little physical isolation. The other thing it has on is a way to control the voltage from 0 to 120. I'm sorry. There's a line. I'm playing to a very isolated area over here. Anyway, why is that important? It's important if he has a piece of equipment that you don't know what its situation is. Ordinarily, before I would probably use up, I would take this chassis out just to see what's going on, because most of the time it's been repaired, sometimes it's been repaired questionably. I've seen, believe it or not, people where they've put the tubes in the wrong sockets. It's a good idea to kind of see in general what you're dealing with before you decide to apply the power.
We have an interruption. The audio on the live stream is terrible. The audio will feed you the live stream.
Okay, I can't really do anything about that right now.
Okay, well, there's no usable audio on the live stream at all.
Okay. So here we go, just for you us then. So I've already kind of know what the situation with this radio is. I know it's not going to blow up on me. I'm going to bring it up anyway. Let's just kind of see what it's going to do.
Are you using your mics at all? Can you turn down any of your mics? Can you turn that mic off?
I don't know.
Okay.
All right. So what I'm doing is looking for filament, which I've already seen with like the pilot light. If you get the pilot light, that's a good indicator your filament string is probably okay. What I'm also doing is looking for how much it draws. It's not such a huge deal on these AA5s, but if you have a piece of expensive equipment that has a lot of nice power transformers and stuff, you want to know what it's drawing before you go hog wild, because you can take out the power transformers or any other piece of expensive equipment. So this already kind of works. It's not unusual. Sometimes I get these things that are even older than this and they have net new or net old components in it, and they still work perfectly fine. But you shouldn't let one of these go back out into the wild like that, because those components that are in it, especially the capacitors, are probably either no good or very close to being no good. Let me change glasses here. These are my reading glasses. So I'm going to identify a few components that you're going to see and replace an awful lot. And most of the time when you work on these, you're going to be replacing a lot of these guys. These kind of nasty, brown, waxy looking things. Those are generically called paper caps. And what is a capacitor? Well, these capacitors are essentially really tightly wound aluminum foil that has aluminum oxide in between those layers and an isolating dielectric compound. Problem is that over time, that foil, well, the oxide can fail, and then they can either short or they can essentially stop capacitating, if that's a word. What typically goes bad in these guys are the electrolytic capacitors, and they're usually almost always the hugest capacitors in your set. AA5s, generically speaking, I'm usually seeing anywhere from 20 to 40 to 60 microfarads, anywhere from 2 to 3 electrolytics. The other thing I do when I work on these sets is I want to determine, is it a true hot chassis set, meaning one end of the AC line goes to the metal, or B, is it what I usually see, which is called a floating chassis. And a floating chassis means that your grounds are eventually going to the chassis, but it's going through a capacitor. And they did that because a lot of manufacturers wisely determined it's not a great idea to have everything coming out of your line going to that metal chassis, because you'd electrocute the crap out of yourself. So this one, I already know by looking, has a 2-gram capacitor that is, just look for the capacitor that goes to the chassis. And where is it? Tell you the story. I had 3 different radios that I brought in today. And they all, here it is, I'm sorry. This capacitor right here is the single most important capacitor to replace in this radio. Because not only is this the wrong type of capacitor, it's the wrong value of capacitor. This is a 0.0, here's the other thing too, the values are written almost always on the caps. That's the short name we give for capacitors. If I hold this up, it's kind of hard to see with this camera. You'll see the writing here. It says 0.05 MFD, microfarad, 200 volts, voltage, DC. So why do we have these electrolytic capacitors here in the first place? The reason is because your AC coming out of the power plant, let's see if this even shows up on this camera. I'm sorry guys, this camera is really awful. Let me try to explain this visually. So the power is coming out of your power plant like this. It's doing it about 60 times a second. What this radio wants is DC. The problem is that all of that back and forth is going to create an awful lot of nasty noise on your audio. And so you need something generically called filter capacitors. And what a capacitor does is essentially charges and discharges over and over again, 120 times a second. Is that right, John? Okay. So the capacitors can help smooth over, making up from what's getting past your rectifier and what's getting from the power plant. So it can smooth up that noise. This one doesn't do it. I was hoping to find one that made an awful motorboating noise, because most of them, you plug these things in, they're like, wah! And it's because the capacitor is no longer charging and discharging. You no longer have any filtering of that AC. So a big part that I find working on these is just kind of staring at these for a little bit. That's why I had to come in early and look at it, because I'm like, it's kind of like complicated three-dimensional Tetris. It's like, where can I put components? Where can I sneak things? And this one's a little more challenging because the capacitor itself is actually mounting terminals for the positives and the negatives. So this is our two positives. This is our negative over here, and it too is floating around. So I had to think about, what am I going to do to mount my replacements? And that's when you can use things like this terminal strip. One magically already appeared here, and we'll talk about him in a little bit.
Pardon me, can we lower the camera?
Oh, yeah. How's that? Well, let's get it to stay.
Hold on.
The horizontal can surely come down quicker.
And your web audio is now good. It fixed itself.
See, that's why I love coming here. We have a bunch of technical geniuses
It
here.
fixed itself. Want to come down a little more?
No, I'll hit it.
Oh, I was that close. Okay. All right. Okay.
I'm sorry, guys. So ordinarily, that's good. That's good. Ordinarily, I would replace the electrolytics first, because usually they're bad. And then that way I can know whether or not that is actually the problem versus something else. But since it already works, and because I want to show you guys how to do some generic capacitor replacements first, we'll do that. So tools, to me, are super important too, especially good quality tools. I'm a big fan of Exolite tools. Yes, they're kind of expensive. I've had some of these for 20, 30 years. I'm not sure if I'm like a lot of you guys, where if you have tools long enough, they become like appendages. Like, this feels like it's part of my hand. And what I do to try to save my place when I'm replacing things is just kind of leave yourself evidence behind, so that when you have replaced, like when you clip one end, you have something left and remind you where you were. It's very easy to get lost sometimes in this wire. So this one I can see on the side here says 0.01 microfarads, 100 volts. And to my left here, I have a whole bunch of generic yellow replacement capacitors. I just buy generically 630 volt rated caps. I'm going to clip one end of this old capacitor and kind of get it out of the way. And I'm going to leave this kind of long wiggly, that's okay, we can clip that out later. Another thing that some people who start doing this hobby do a lot initially is they'll leave their leads way too long. And that can affect your set's performance. So when you're in here, try to keep your leads as short as you can. Especially true with FM sets. FM sets are really, really sensitive. AM sets, not so much. Also get good at kind of eyeballing how long you need to make your leads. And sometimes you can I can tell that this one just needs a little bit of clipping. And what I do when I prepare my leads, and there's something called a pigtailer, which I'm sure would do a much better job. I just make a little hook. Pre-make the hook, and I kind of look where it's going to go. I figure I could probably shove it down this lead easier by aiming it this way. And you want to make a good physical connection. And what I'm going to use is it's not mine, actually, it belongs to the museum, but I have one of these at home. It's called a Metcal soldering station. And it uses induction. What I like about it is that this tiny, very lightweight pencil, it's almost like a cigarette holder type thing. It's very comfortable to hold. And it's got a tiny tip, it gets really hot very quickly, and I can do really nice fine work with it. So I can, and this is another thing that's critical. If you don't solder properly, that can cause all kinds of problems. So what you want to do is touch the work first and get it kind of good and warm. And then touch it with your soldering iron and just, you want to get it molten. I'm not sure if you guys weld. It's the same principle. You want to make sure that you're making a good physical as well as kind of a molten metal bond there. And now I can come in and clip the excess lead out. Now, there's debates about a lot of different things, and again, there's lots of different ways you can do this, and I think in often cases, there's no wrong answer. It's just the way that you prefer to do it. Some people like to come in and loosen every single lead coming off of, for example, this socket here, which is fine. The issues I've had with that is sometimes there's items I'm working on that are very sensitive and delicate, and if I were to do that, I would risk damaging some of the components. So I generally just try to make sure that whatever I'm soldering definitely has a good bond like that. I'm going to attach the other side. And again, I'm going to try to make a little loop here. You'll get better at it the more you do. Kind of make sure you clean your tip between soldering. It'll get a bunch of gunk that'll build up on the tip. You want to make it clean. Now you see how that just came off? It's live television, folks. It just fell off of there. Give me a quote unquote resolder that back on there. Didn't wait for it to cool. All right. So now you see how there's really no wiggling going on with this capacitor. It's pretty much a straight line, that connection. That's ideal. Now, sometimes you'll get into some of these areas where you're just crammed in there, and sometimes if you can't see what the values of these are, you can just use your thumbnail. Just scrape the wax off. I think this is paraffin wax. This one says it's 0.05. Now, the other critical capacitor in here is called the across the line capacitor, which is exactly what that is. And the easy way to tell if it's across the line is if you just trace where your AC cord comes in. Does it ultimately terminate either on, usually it comes off of the switch and then the other side of your AC cord. So you see here's one side of AC. The other side is over here coming off of rectifier tube. And this capacitor is going here into the other side of the switch. That's across the line. You'll open up a lot of these guys, especially the ones with the bumblebee caps, to where these will have exploded. It's because if the set gets struck by lightning or there's a surge or anything, this type of capacitor really can't handle that. And the problem with this kind of capacitor is if this were to say fuse and short solid, then this set becomes a real hot chassis set instead of a floating chassis set. And so that's the danger. We want to replace it with one of these. This is let's see if I can read the tiny copy on here. It's an X2Y1 capacitor. And what these will do is if it's struck by lightning or something horrible happens, it's actually going to split. It's going to break. The connection will essentially sever itself. So you will not get that awful situation I was talking about where it just becomes like essentially a hot chassis. So that definitely needs to be replaced. So I'm going to replace that next. And again, I just chop one end of the old capacitor off and leave a long lead to give me a point of reference. I'm not sure if it shows up on the camera, but you can kind of see there's this nasty powdery white stuff. And if I look on the end of this capacitor, you can see there's a hole. What that means is this capacitor is probably shorted open already. I've seen a few of these where you open them up and the end is just completely incinerated. So it's time to go. Also wanted to make something clear for those of you who have rebuilt 10,000 AA5s. You don't have to watch me recap this whole radio. So if you need to take a break or move to something else, you won't hurt my feelings. Okay, so let's get this other side of the across the line capacitor replaced. And you see, I want to keep it just as short as I possibly can. I do not want anything to bounce around, to hit anything else, or to cause any sort of interference with the radio.
Is there a name for the capacitors that split like that when there's a surge?
A name for the for the capacitor when they split open?
Or the name for the capacitor itself?
Well, this is the capacitor that was in. What they did, they were using regular capacitors as they would use throughout the rest of the radio, but they did. I don't think they quite understood. Well, maybe they did understand. I'm not sure exactly what the decision. Probably because it was cheap, but.
Ceramic capacitor.
Ceramic capacitor?
This one, yes.
Yeah, okay. Thank you, Kent.
Sure.
All right, so let's replace a few more while we're in here, and then I'm going to show you, well, let me,
So I got a question on your strategy here. You have looks like at least a dozen capacitors there, if not more. Is your strategy basically, since you're in there, just replace them all, or do you replace one and then kind of test it, see if things are better?
what you should do, and that's a very good point, is before you get too far along, make sure the radio still works. Because I've done that a lot where you are like, I've done like 10,000 of these radios, I can do it. And you just cap the whole thing, you plug it in, and it doesn't work. And that's the worst kind of feeling ever, is when I restored a radio that worked and now it doesn't work. So that's ordinarily how I would do it, and that's how I would recommend everyone else do it. Okay.
In other words, test after.
Correct. That's what I would recommend. I'm going to replace the oh so important 2 chassis cap to reiterate the other side of your AC cord. This is kind of shoved in there. And again, this is critical. We want to make sure that we use an X2Y1 capacitor to ground. What we're doing is we're dropping the capacitance. This is a 0.05 rated capacitor. Probably give you kind of a little bit of a tingle. It wouldn't feel very comfortable. But when we put a 0.01 rated capacitor, that drops that potential of getting to this chassis even further. So I'm going to do the same thing. I'm going to just clip one end. And then attach one end of the new X2Y2 across the line cap. And again, I want to make sure that it's not just a solder. It's a good crimped physical connection. You'll see I kind of like hold the soldering iron to the work until I see it absolutely melting into every little nook and cranny of that connection. Just realized something. I was nervous and just disconnected the wrong capacitor. Let me fix that real quick. Okay, rewind for just a second. We're going to replace this capacitor with this one, sorry. As you can tell, I'm probably not going to win any Golden Globes awards for this performance. Anyway, I've been doing this after work for probably about 10 years, and there's something extremely satisfying about it. So when the day is done, I just can't wait to go out into the garage and start working on radios. Okay. Sometimes you have to get your fingers in there to move things out of the way. And do weird gymnastics like I just did. Okay, back on track now. Let's replace the tooth line capacitor. Sorry about that. So this is it. I know one side goes to chassis, so in this case I can just clip both sides out and give me a little bit of room. When I used to do this, when I was first started, I would just put capacitors here, there, everywhere. But if you start moving stuff around dramatically, again, that can affect the performance of your radio, and that's sometimes why you have to go in and do a realignment, because you throw things out of alignment. How far did some of you come today?
Vallejo?
Vallejo.
Not too far.
Oh. I went to Vallejo for a pirate festival years ago. All right, so let's get this other end of this safety cap soldered in on this side.
Can I ask you a question while you're working?
Yeah.
I'm surprised at what a mess the wiring is. Nothing's parallel, nothing's right. Is that typical of these?
Yes. I've you know, when I've put a few of these online, and it's amazing. I'll get comments from 20-something-year-olds, and they're like, "That looks insane." Like, is that really how it was? Like, yes, it was. They were all these big, rat nesty sort of. That's how electronics were. They were all direct point-to-point wiring. And believe it or not, it was the way to go forever. Zenith, Zenith Radio and Television, the quality goes in before the name goes on. They were so insistent on hand wiring that they were, I think, one of the last major manufacturers still doing it in their TVs, I think even well into the 60s, because they tried PC boards and the heat from the tubes caused damage to the boards, and they weren't nuts about that. Okay, so now we have the two most important capacitors replaced. We have the cross-the-line capacitor and the grounding cap, the chassis grounding cap going to the other side of the AC. So now we've made this set hopefully just a little bit safer. And now I think I'm going to go ahead and start replacing the electrolytic capacitor. And the first thing I need to do is get this guy out of here because I need to make some room. So I'm going to have to do some brute force here because it's strapped in.
If you come across one that doesn't have a capacitor to the chassis, can you add one for safety?
Hmm?
You said to check to see if there's a capacitor always for the chassis. If you find one that doesn't have that, can you add one?
If you don't have a chassis, if you don't have a capacitor going to
Separating the chassis from,
on a hot chassis set,
yeah.
you'd have to have something, because you have to have, like, basically the capacitor bridges the gap between your AC. So if you didn't have that, it's probably going to be a hot chassis set, meaning that this prong is going directly to.
I guess asking, can you retrofit a hot chassis set?
I I guess you could, but anyway, maybe we can, that's a good future class, who knows? All right, so let's use some brute force to get this capacitor out of here. Okay. There we go. That wasn't too much hassle. Let me clip my negatives off. And get my positives, because I just want to get this huge thing out of here to make more room. Now I can see what it says. Motorola, this is all positive. That's all negative. And what's the values? Huh. See where it says 2020? This is weird. What that's trying to say is it's 2 20 microfarad capacitors at 150 volts. And when it comes to capacitor replacement, you want to make sure of two things: that your voltage and your capacitance is at or greater the voltage that the piece you're working on has. I mean, you can go over all you want to some degree. I mean, I wouldn't go nuts with your capacitance, especially for your rectifier, because it'll beat it up a little bit, but you can pretty loose and wiggly with this kind of radio. It's kind of amazing. I've had a few of these that came in from a no-name manufacturer with no information on it, with nothing printed on the capacitors. And if you flip open an RCA2 manual, in the back of it, there's a generic radio diagram, because RCA basically patented almost all the technology today. And what was that laboratory name? Eagleton. Yeah, Eagleton. They just owned all the patents. So if you can generically get away with putting guesstimated close enough capacitors in these, and they'll generally work. I hate to say it, but they're not very sophisticated machines. And it's amazing how well they work for what they are. So now that I've got all of this area cleaned out, what can I do with it? I know I can put in this convenient terminal strip that just happened to find its way on my desk here. Please don't lose the hardware on the floor. So what I'll do is make a nice little terminal strip here. And I think I need to turn that around, because that's going to hit the front of the cabinet. And by the way, make sure that you do not use any of the lugs that go to chassis. And don't ask me how I know that that's a bad idea. Come on now. This gives me a new appreciation for Julia Childs. It's like she probably had like 5 chickens already prepared. This chicken is already cooked. All right, so we have this terminal strip here, and I added this terminal strip there. So now I have all kinds of places to mount my nice new capacitors. Now this one had 2 capacitors inside, and you could go out and try to find an expensive one that had several values inside, or maybe even those exact values. Or you could go to Mouser Electronics and buy a whole scad of these guys. I buy these by the ton. 47 microfarads at 200 volts. You can actually get away with 160, because these only ran on 120 volts to start with. But if you want to be a little bit of just be a little safe, go with 200 volts. So now what I'm going to do is start mounting my electrolytics. And when it comes to your electrolytic capacitors, your stripe is always going to be your negative. Well, not always. Sometimes you'll see negative expressed in a different way, but most modern capacitors will have your negative here. So if you see that, by default, that's your negative. Do not put them in backwards. If you do, they will explode dramatically and possibly spray confetti everywhere. and make your ear go numb. So make sure you observe the polarity. And speaking of polarity, what we're going to do is attach the positives, both positives here, to the positives of the new electrolytic capacitors. And then we also need to have their negative shared. And I'll explain that as we go along, because trying to explain it visually is kind of difficult. So what I'm going to do is put my positive lug through this terminal strip, and at the same time I can use, actually let me think about this for a second. This is what I mean about doing 3D Tetris. What would be better? Okay, change of plans. I'm going to put the positive here and move all of these positive connections there. And you can see there's one lead coming out of this transformer here. I didn't have a lot of room, so the terminal strip had to go there. What I'm going to do is cut my lead as short as needed. And come in and just weld all of that together. Don't be afraid to use a lot of solder. Solder is, I was about to say cheap. It's not really cheap anymore, but it's a good thing we have about 500 pounds of it here at this museum. The good stuff too. All right, so now we have all those positives taken care of. We've got one left. This little guy. Where can he go? And the other thing too is I'm thinking, how can I neatly wire the negatives together? And I think I just, by looking at this, may have come to a possibility. All right. Let me get this lug material off of this one. Also, do not drop metal bits in your radio like I just did. It's good to give it a shake when you're done too, just in case. Oh, and don't use steel wool. For God's sake, don't use steel wool around electronics. What I'm doing is roughing this up a little bit. You want to make sure that, especially if you have old contacts like that, that it's good and clean. So I'm gonna, sometimes if I've got especially an old surface like that, I'll try to pre-tin it. And that way I know when I come in with what I'm going to attach to it, it'll stick. I think what I'm going to do is I'm going to run the second positive through that opening, and now I can run my positive of this hydroelectrolytic right here. Again, you want to kind of keep your leads as short as you can because you don't want stuff to move or wiggle around. Okay, let's solder this in. Voila. So now we have a means in which we could possibly neatly tie my negatives together. Except I don't want that much of a lead sticking out in the willy-nilly. So this is called redneck engineering here. I'm too cheap to go out and buy shrink tubing. So what I do is I keep rolls of wire around my house and I just strip off some of the insulation. Watch as I go flying across the room. All right. All right, so now that's sleeved and I can just kind of hook it into this guy. And yes, the electrolytics are often the most cantankerous things to replace because you're often, most of the times, changing physically how they were oriented into the chassis, because most of the time the electrolytics are either on top or off to the side.
Is it that you can't find packaged ones like that anymore?
You can, I mean, but like they're often kind of spendy versus these guys, which are, I don't know, if you buy them in bulk, they're $1 maybe, even less than that. And you don't have to make it look neat like that. I just, for some reason, I'm OCD. I like to make it look neat. Okay, so now we've got our two positives, one here and one here for our two replacement electrolytic capacitors, but they're orphaned from their ground, which is over here. Now here is where I want to make sure that this is not going to cause me as much trouble. I'm going to cinch this up just a little bit and add a little solder. The idea is you just don't want stuff to move around. That's not going to go anywhere. So I'm going to run a line. I guess I'll use this wire instead. What I need to do is run a jumper between the negative and the negative, the two new electrolytics that are tied together. So again, I kind of pre-measure.
So the original capacitor had two capacitors in parallel in it?
Well, what it is that you've got, see here's two capacitors, you got 1 and 2, the white and the red dots.
Okay.
And so that you've got two positives going out this way, and their two negatives are joined together here. Does that make sense?
Yeah.
Okay.
They're in parallel.
Okay. It's not my favorite wire, it's pretty stiff. Okay, now you want to kind of keep this stuff as short as you can. I'm sorry, guys. I did not anticipate how to do one of these videos live like this. Because usually I can just stop the camera and be like, people don't want to watch this. It's like,
Crack a joke.
all right, so we've gotten to a point now where I think it's actually more than enough of a point to try it out because there's only 3 capacitors left to replace, but let's test it just to make sure that we're still firing on all cylinders. At this point, I just took the antenna off. I can alligator clip it in. And let's get the other antenna lead.
So since you're live on Facebook, right?
On what?
Are you live on YouTube?
Yep.
How many people got on?
All right, so let's try out the radio again, see if it's gonna do its thing. Or will it fail? Or smoke, who knows?
Yeah, well, that's-
Reverse capacitor?
I couldn't put the capacitors in backwards,
Thanks for more drama.
Yeah. It would have been.
or maybe I just invented something that opens a hole in the fabric of space and we're all about to be teleported. Yeah, black hole. It works. Let's take a break from replacing capacitors and do something that's maybe a little more fun to watch. How about that? So, kind of interesting. I'm looking at this. This has a field coil speaker in it. That's interesting. So here's some things that you'll want to do to make sure your radio is good and healthy for long-term usage, and also to make it more pleasant to use. So this is the tuning condenser. It's got a bunch of very thin plates that kind of do this. And that's how you tune your stations. Problem is it gets filled up with dust bunnies. And thank goodness we live in a land of cheap electronics, because I bought this recently. And I just realized how stupid this would be to do this facing the crowd. So I'm gonna. So I've cleaned all the dust and stuff out of the tuning condenser, and I'm not done yet. That's why I keep these old toothbrushes around, especially if I go to the dental office and they're like, here, have some toothbrushes you'll never use. You can go in and just kind of gently pull in one direction. Sometimes what happens is that you get cat whiskers and dust bunnies and all kinds of other things. Kind of move it around. You want to make sure you get not just those, but their conjoining brethren up here. Now that we've got all the dust out of there, let's do the next thing, which is we need to oil the bearings in the front and the back of the tuning condenser. And what you'll see, trying to figure out to get the camera in there. In the front, you'll see ball bearings. And all I want to do, I use this stuff called Zoom spout oil, but more particularly I just like it because it's got this extremely long oiler tube. And Kyle, if you're watching, he taught me a cheap trick, which is you can just go to the automotive store and buy 5W20 synthetic oil. I'll do exactly the same thing. You want synthetic because it's never going to solidify and harden up. So what I did is I just kind of wet those bearings. And I'm just going to put a tiny bit in the back. There's a bearing surface in the back. You want to get that. Just look around. What else moves? We have all of these bearings now. Before I continue, do not get any on the string. So I'm just going to just touch a little bit of oil. If you overdo it, it'll make a mess. And likewise, I want to get a spot here as well as inside.
What do you know what sewing machine oil is equivalent?
It's pretty similar. Generically speaking, any sort of light machine oil will work. That's already so much nicer. If you're doing this for other people, like they'll notice it, they'll be like, ooh, that feels nice. It's tactile. But we're not done yet because that's still not as smooth as it possibly could be. So this is when you get a little bit of oil on your finger. Or wear gloves, we don't like doing that. And just kind of rub, slide that the tuning indicator goes on. Front and back. This is pretty clean. You can't tell from the video, but it does feel nicer. Okay, that was interesting. Now, while we're in here talking about cleaning and oiling things, this is where we need to take care of the volume control. Because the volume control has been sitting here for 70-something years, and there's probably debris that has gotten into the pot. Generically speaking, we call these pots. And the volume control is going to have 3 legs on it. Top, bottom, and the center. And most of the time, where you see those legs going through, there's going to be a little slot, a little hole, and that is the access to the wiper. And all this is just basically a big mechanical resistor here. So you want to make sure that's clean so it sounds smooth. So I use this product called Deoxit D5. Actually, I'm lying. If it's my radios, I'm a cheap person and I use WD-40. I know a lot of people are going to boo about that. But anyway, because I have to be good here, I'm going to use the real product. I'm going to use Deoxit. You don't need much. Good thing too, because this stuff's expensive. I'm going to work it in there. I usually spray an initial amount and then spray more because that'll flush whatever you just broke loose. Here's another little trick that I learned over the years with these switches. Sometimes you'll get these in where they won't click when they turn off and on. You're like, oh no, the switch is bad. I guess I'll have to replace that. Well, these switches in the back here is a kind of a spring-located, let me get my pointer here. Where'd it go? See what's cut in half here? The back here is the switch part, and there's a little spring-loaded mechanism in there, and that often gunks up. If you spray it with WD-40 and then hold your soldering iron on the lugs back and forth, the heat will go inside and loosen up the switch most of the time. So then you don't have to take the switch apart. So just a little thing I thought I'd share with you. I think what I'm going to do now, since we've replaced enough of the capacitors for it to work, and it seems to work well, I'm going to show you some other part of the process where you can add audio to your radio. We started doing that a few years ago because there's not as much music to listen to on AM anymore. And most people that are coming and getting things from our museum want to have the ability to play their music. And it's not that hard to do. These sets essentially have all the necessary ingredients. You have an amplifier section, you have a speaker, and you have a volume control to control it. And the volume control, all it cares about is making the radio signal either greater or lesser. It'll do exactly the same with an audio signal. It doesn't care. It's just a big resistor. And so what we need to do in order to make that doable is, first of all, think about the safety potential. Because you do not, what we're going to do is run a audio cable where someone can plug in who knows what. It could be Bluetooth, it could be Purple Tooth in 20 years, it could be who knows what. But we'll probably still have a 3.5 millimeter stereo cable, hopefully. We can't just run this directly to the volume control because there's the possibility that current could get back to the user. And that's not a good thing. They could get it through here. So what we're going to do instead is run it through something called an isolation transformer. It's very similar, kind of like what's on this workbench here. It's going to do the same thing. And a lot of people ask, where do you get your isolation transformers? And the answer is we buy them. This is what they look like. We buy them by the bulk from Alibaba. But you don't have to buy these. You probably already have a bunch of these in your house. If you have a desk drawer like me, filled with 10,000 wires and lots of wall warts and stuff, then just take one of those wall warts that you haven't been using anymore. Chances are you've got one that does something like 120 in with 12 volts out or 6 volts out. That'll work just fine. You crack them open. Your primary side will be your 120 volts coming in. Your secondary side is your low voltage. That's what this is. This transformer, the primary side is 120 volts on that side. The output, which is a secondary, is 12 volts. But we need to do a few things before we run this signal in. And I drew it out. Let's see if I can put it to where, get this radio out of the way. Sorry, guys. Is that upside down?
Yeah.
All right, can you see that? All right. So what we're going to do is run audio into the radio through the volume control. And that blue device I showed you, that's the isolation transformer. And what we're going to do is turn our right and left channels, because this is a stereo connection, into mono. But you don't want to just twist those together. You want to run them through a set of resistors. And what I generally use is between 20 and 50 ohm resistors that can be tiny little quarter watt guys. So your right and left channels are tied together. On one side of the secondary, the other side is your ground for the cable. And on the primary side, we have one side going to the bottom of the volume control, which is essentially usually the negative of the set, usually negative of the floating ground. And then the primary is going to the top of the volume control, which is where the incoming radio signal comes. But we want to do a few more things besides that. We want to add kind of a secondary isolation device, because if you keep this transformer in the circuit with this volume control and this radio, cassette has something called an automatic gain control feature. It's going to interfere with that. And we found by trial and error that that can interfere with the set's fidelity. And so if you put these two together, that'll kind of cancel that out by isolating that part of the circuit from the volume control when this is when this is not being used. The last thing we want to do is make sure that we can turn the radio signal off and on. So if someone wanted to go back and listen to the ball game or whatever it is on FM or AM these days, they can. And so we'll run a switch between the connection of I think it's the first audio, Jimmy? Remember, the first audio coming directly to volume?
Yeah, going in the first.
Yeah, okay, yeah, exactly. So that's what we're going to do. And if anyone's watching online, take a screenshot of that. I'm going to do a little bit of Julia Child's magic, which is I already kind of manufactured this. And when you're done, it's going to look something like this. This is what's underneath. We have our 227, this is what I just happened to find. Like, again, it's kind of arbitrary. I have these two 27 ohm resistors tied together. Our right and left channels are going to go here and here. Our ground will go here. This is, again, your secondary of the transformer. And then the primary has this small cap and a resistor. And the resistor is half the value of your volume control. And most of the time, the value of the volume control is about 500K. So figure 240, 250K, somewhere around there. Again, it's a little bit arbitrary. And then you want to run your leads going to the volume control, which is just these two leads, these skinny guys. And then this is the audio cable. Now, why do I have this glue on here? The reason I have the glue on here is because this will get glued inside the set. And I've never had one come loose, but I'm not sure what's going to happen 20 years from now. What if this came loose? And if that came loose and you have all these exposed electrical contacts, they could hit something inside. So I decided to start doing this epoxy treatment so that if it does come loose, it's just a big hunk of plastic. So let's go ahead and add that bad boy in here. And then we can see how that sounds. Here's the Bluetooth device I'm going to use, and we have a bucket of these downstairs. I think we ordered a bunch of these for 99 cents a piece. They're insanely cheap. This cable, by the way, is way, way too long. So what I'm going to do is I'm going to see where can I put it. It could go exactly right there. That'd be a perfect place for it. So I've already roughened this up, and I want to roughen the metal that it's going to attach to as well. I'm going to use Gorilla Super Glue. I'm not saying you have to buy that brand, but sure. I like the fact that their caps don't get clogged up. Okay. Again, that looks like a nice place to put it. And just stick it right there and hold. Just got some of my hands too. And now I can like pull this cable. And what it is, I put a knot in this so you can't yank it out, but you don't want to have this loose wiggly stuff going on. This could possibly interfere with the radio. So I'm going to cinch it up.
Are those just holes you found there, or did they drill?
Oh, let me explain this. So I drilled a hole in the side, and also if you go to Harbor Freight, they have these kits. You can get like 100 different grommets at a time. And I put a grommet through the hole because you don't want someone doing this or that. They could cut the cord.
But you drilled the hole.
Yeah, I drilled the hole.
Okay.
And I especially like these stepper drills because you can basically easily adjust for whatever size of grommet you got. All right, so let's run our cables to the volume control. I'm gonna have to admit that I kind of cheated a little bit because I was like, on these, sometimes cutting the radio signal is a little more complicated. This one's pretty simple. Because what we want to do is make sure that we can connect and reconnect the radio signal after we're listening to the Bluetooth. And the connection for that signal going to the volume control just happens to be right here. So if I take this off, you're not going to get any radio. Instead, you're just going to get a little bit of hum. You'll essentially be just turning the radio into an amplified music box. So I'm going to disconnect that lead. And I'm going to then I want to keep these leads from your isolation transformers absolutely short as you can, because the longer they are, the more there's a possibility it'll cause audio distortion. Got all tangled up. Okay, I know that I can run to, okay, now I can cut to length. That's as short as it needs to be. This is my negative ground, this black wire, and my brown wire is my positive. That will be going to the top of the volume control, which in this case is actually on the bottom, physically, down here. See if we can get a better picture of this. But what I'm going to is this lead, which is on the bottom. This is essentially the radio signal, and we're going to tap into that so we can borrow it temporarily for audio signal. I'll tell you one thing I forgot that is very handy is my hemostats. My dad has a friend who's a surgeon and constantly gives him all kinds of nifty tools, and the hemostats are fantastic for weird electronics like this where you can't get into places. Okay, that's the top. That I think is the bottom, and we'll find out in about 30 seconds because we're going to run some music through it. Now, that little device is going to connect to my phone, hopefully. Connecting. It's connected. All right, let's go ahead and fire it up. Let me make sure I didn't move. Also, I had my fingers in there quite a bit. Let me make sure I didn't get anything in the way. All right, good. All right, here we go, bombs away.
Do you have the radio plugged into AC all the time you were working on it?
No.
And your antenna lead came loose while you were joggling everything around.
Well, right now
I mean, if you're gonna look for an actual radio.
right now I'm running the audio through. So right now, temporarily, the radio signal is disconnected.
Right, okay.
Yeah.
And so Bluetooth is your only source.
That's heavy on my mind. Then I look at you. And the world
So now,
right with me.
like I could walk around my house and just play the radio. If I didn't like that song, I can change the music. Now, you're not going to win any sound contests. These usually have 4 1/4 little pie pan speakers that are full of holes and everything. But this one's actually got kind of a decent speaker for All right. Now, speaking of speakers, oftentimes they are ripped. There, I turned it off, John. You can see there's a lot of little creases and stuff in here. Actually, that's just, what is that? Spider webs, never mind. But if you do get these and they have cracks, especially around the perimeter, I see a lot of people where they just get wood glue and they fill it up and then they're like, that sounds terrible. Of course it sounds terrible because this needs to move. That's why they're called an air pump in some cases. So if you do need to fix the speaker in an area that it moves, use a product that doesn't ever get hard. This is a flexible clear glue. You can use silicone because you want it to move just as much as that paper is going to move. All right, so I'm going to show you couple more tricks, and then I think I'm going to conclude. I want to thank you all for watching. This actually means a lot to me, and I've learned a lot, and I can tell there's a bunch of things that I need to do differently. But okay, so oftentimes we'll get these Bakelite in plastic cases, and a lot of people's impulse is to immediately take the radio case and dump it in their kitchen sink and scrub the crap out of it. That's the absolute best way to ruin Bakelite. And the reason is because Bakelite tends to be the same organic plastic. It's made out of phenols, resin, and ground up jute rope in many cases. So what makes them shiny is the casting from the factory. And when you start, all you have to do is scratch that or abrade it, and that surface is gone. Now, unfortunately, this is a Bakelite case, but it's painted Bakelite. But what I use on Bakelite is this, it's Carnauba car wax. Gold class is a little more expensive, but it also smells nice. And where did my rags go? Did Steve take my rags?
Oh, you put them over there.
Where do you put them?
Over there. To your
Okay.
left.
Let me see
I
if I
can
can-
grab it.
Thank you. The microphone.
We're not letting you go until we're out. Use your shirt.
Thank you. So pretend this is Bakelite instead. I'm just going to show you. What I tend to do is I don't clean it. Instead, I'll get a cleaner Carnauba wax in a paste form. I didn't bring it, but what I've got is a mechanical buffer that I have for my drill, because this will absolutely crunch up my hands. It's kind of probably hard for you guys to see on the camera.
You can see it.
See how filthy that is? It's paint. The lovely thing about paint is that you can always resurface your paint. In fact, if I get one of these that has the original paint, it looks pretty decent like this. I try to keep it like that because that's been on the planet for 80 years. And so what? It's old. See how much better that looks? Probably if I went over this whole thing, I could make it look like new. I think that is what I had for today. And I wanted to thank you all for coming and watching. If you have any questions, I'll see if I can answer them.
When you put the Bluetooth in,
Repeat questions, please.
I'm sorry. Oh, when you put the Bluetooth in there, did you put another capacitor in or something? Somehow I missed when you were going from the radio to the Bluetooth. How did you do that again?
Could you repeat your question?
He wasn't sure of how the audio got in through via the Bluetooth.
Yeah, that's correct.
It's via this. So that's an isolation transformer.
Okay.
And one side is, like if you have a wall wart in your house where it's like 120 volts in and 12 volts out, it's the same thing. And what you want to do is run your audio through that, because what that's doing is it's doing the same thing that this does for me, which is it prevents you from becoming part of the circuit. And that's just an additional layer of safety, just to make sure if there's anything coming out of this radio electrically, that it's not going to get to you via that audio cable.
Okay, so can you still play the radio and the Bluetooth then?
What I would do ultimately in the end is you have a little switch that decouples. So there's your volume control, and there's a top and bottom, and your signal comes in through the top, and you want to basically put a switch between that connection. So think about it this way: your radio signal is definitely it's a positive voltage, even though it's probably millionths of a volt. You're just cutting that so that you can use the volume control instead, and the set's internal audio amplifier to amplify that the signal coming out of your Bluetooth.
Okay, and where did you put this then?
That goes, see, between your audio cable and your volume. So your secondary is where your audio comes in. Your primary is what goes to the volume. You can have this if you want, actually, because I'm not going to do anything with it. But, and that's the neatest I've drawn in forever, because I can't write my name anymore.
So you put this in the radio itself then?
Yes, it is. It's, right now it's right here. See it up here? Yeah. Oh, just about dropped it. Yes.
When you're looking for radios to like work on or purchase, is there something you're specifically looking for? Are there any like red flags that you're trying to avoid when you're just sourcing out radios that you couldn't build to repair?
We get probably hundreds of radios as donations here, and so what we do is we fix a lot of them for various events. And as one of the volunteers here, I take some of them home. I work on them here. You'll see a lot of it happening in the shop. So it's just something we do to try to get these radios out of the landfill, because a lot of the radios like these, probably a lot of collectors these days wouldn't give this a time of day. But then we make them to where they're actually usable, and you can listen to something besides AM, and that seems to go well with people. That's why there's a bunch of them over here actually in the corner. That's a bunch of those that we've done in the past. But anyway, I'm gonna go ahead and end the stream here. Exit.
Thank you. Take it home for my grandson. Do you work on the tube radios?
Tube radio?
Did you work on the tube radios too?
Yeah. All right, let me try to end this.
That's what I've got.